All right, we're going to take a look at the other three types of problems now. We'll start off with the easiest of them, the mol-mol problem. The problem reads, if 30 moles of oxygen react with hydrogen, how many moles of product get made? Well, we all know if oxygen reacts with hydrogen, it forms water. So the very first thing we want to do is write a complete imbalance equation, remembering that oxygen and hydrogen are both diatomic. And then to balance it, you need two hydrogens and two waters. So take that reaction, and you be sure to pull out the numeric information and write that above. And then how many moles of product? That would give me X moles. And since these are both moles, I'm writing nothing down here because I don't need any molar mass. So nothing needs to go there. The mol-mol problem is two steps. I'm going to start with the 30 moles of oxygen. And so I want moles of oxygen to cancel. So moles of oxygen is going to go in the denominator. So it will. And I am going to put 2 moles of water on the top. So mathematically, what I'm going to do is I am going to take 30 times 2 divided by 1, and I have 3 sigs working in the problem, so I have 60.0 moles of water produced. Let's take a look at a mol-gram problem next. I have 6 moles of sodium reacting with water. How many grams of sodium hydroxide will be produced? And if you only have it producing sodium hydroxide, good luck ever getting it balanced. It won't balance. Hydrogen is another product, and that's why when you throw any alkali metal in water, they will catch on fire because the hydrogen will burn. So I have written a complete and balanced equation. I'm going back and picking up my mathematical information and writing that above my equation. And wherever there's a G unit, I'm putting the molar mass down low. And so now I've got all my information in front of me. I'm ready for my 3-step problem. So I start with what's given, which is 6.0 moles of sodium. So I know I want moles of sodium to cancel. So moles of sodium goes at the bottom. And I'm going to or toward moles of sodium hydroxide. So moles of sodium hydroxide is going to go in the numerator. This is called the mole ratio step. And now that I know I have moles of sodium hydroxide in my numerator, I know what will be the denominator of my next one. And I know this would have to be the molar mass step. And the molar mass of sodium hydroxide has already been calculated. It is 40 grams. So on my calculator, I'm taking 6 times 2 times 40 divided by 2. And that will give me 240 grams. That has 2 sigs in it. So do I need a decimal point? Nope. I only have 2 sigs in my problem, so I want to keep that answer the way it is. Let's finish up this video with a gram-mole problem. A gram-mole problem, we are given 43.0 grams of silver is made from a reaction of copper with silver nitrate. It does tell you copper 2 nitrate is the other reaction. In worksheet 1, it was copper 1 nitrate. Some of you put copper 2 nitrate. How many moles of silver nitrate are needed? And so I've got 43 grams of silver that I'm putting above silver. I want to know how many moles of silver nitrate are needed. So I kind of put this in the wrong spot. And see, look, I put that in the wrong spot and I solved for the wrong thing. So this should be X moles. So I've got some correcting to do in my factor label. So I have 43.0 grams of silver. And again, since a gram unit was here, I went ahead and figured my molar mass or looked it up. And so I have 43.0 grams of silver. I'm going to know that grams of silver is going to go down here, so it'll cancel. And that has to be the molar mass step. So 1 mole, and molar mass is always for 1 mole. So I want moles of silver here, but I don't want moles of copper up here. I want moles of silver nitrate. And it is 2 to 2. And so it's 2 moles of silver nitrate. So to calculate this, I am going to take 43 times 2 and divide this by 107 times 2. Well, I can just cross out the times 2's because I know 2 over 2 is 1. So I'm going to take 43 divided by 107. My 43 is actually 43.0, so I have 3 sigs working in the problem. And I get a calculator answer of 0.40186.9, etc. So I go, here's the third sig. This is going to round it up. So I final answer 0.402 moles of silver nitrate. So hope this helped if you were still on shaky ground. Finish working on worksheet 2.